Hey, what's up, Marauders? Welcome back. This video, 3.5, Empirical Formulas from Analysis. What we're going to learn in this section is how to find the empirical formula and then also the molecular formula of a compound given the percent composition. So you learned earlier how to take a formula and determine the percent by mass of each element. This section is going to be kind of the opposite of that. It's going to be taking the percentages by mass and converting them into moles and then finding the formula of the compound. So an empirical formula is the lowest ratio of atoms in a molecule, and it's based on mole ratios, not on mass ratios. So we'll start with this example. You've got 25% by mass hydrogen and 75% by mass carbon. What is the empirical formula of this compound? Well, the easiest way to solve these questions is to assume that you have a 100-gram sample. If we assume that we have a 100-gram sample and 25% of it is hydrogen, then we would have 25 grams of hydrogen. And if 75% of this 100-gram sample were carbon, then we'd have 75 grams of carbon. All right, well, we know that empirical formulas are not by mass, but not by number of moles. It's a mole ratio in the empirical formula. So what I want to do with these is turn them both into moles. So we'll use molar mass. So we'll do 1 gram of hydrogen for 1 mole of hydrogen. That's the molar mass from the periodic table. And then for carbon, we'll do the same thing. We'll look up its molar mass on the periodic table. 12 grams of carbon for every 1 mole of carbon. Okay, and so we've got 25 moles of hydrogen in this sample. And we have 6.25 moles of carbon. So we've converted them both into moles. Now what we need to do is find the ratio between the two. The easiest way to do this is to divide by the smallest number. So out of 25 and 6.25, 6.25 is the smaller number. Okay, so dividing them both by the same thing or multiplying both by the same thing keeps the ratio the same, but maybe it will help us to simplify a bit. So this gives us 1, and 25 divided by 6.25, this gives us 4. So it got us into whole number ratios, 4 to 1. So our formula is CH4. There's 4 hydrogens for each carbon in this compound. Let's look at another example. So this compound has 4 different elements in it. So we have carbon, hydrogen, nitrogen, and oxygen. And we want to find an empirical formula again. So just like before, we'll pretend we have a 100-gram sample. And that would mean we have 59.53 grams of carbon, 5.38 grams of hydrogen, 10.68 grams of nitrogen, and 24.4 grams of oxygen. All right, and just like before, when I have grams, I need to convert those all into moles because an empirical formula is a mole ratio. So I'm going to use the molar masses here. So we'll do 1 mole of carbon is equal to 12 grams of carbon. For hydrogen, 1 mole of hydrogen is 1 gram of hydrogen. For nitrogen, 1 mole of nitrogen is 14 grams of nitrogen. And for oxygen, 1 mole is equal to 16 grams. All right, so you'll calculate those on your calculator, and you get 4.96. You get 5.38. You get 0.763, and you get 1.525. All right, so we converted everything to moles. But we can't leave our formula like this. We need to get it in a whole number ratio. So just like before, the easiest way to do this is divide by the smallest number. So we'll divide them all by 0.763. right? So we keep the ratio the same by dividing them all by the same number. And so this one comes out to be 2. Or if it comes out to be 1.99, that's fine. You can round that to 2, or 2.01. You can round that to 2 as well. This comes out to be 1. For the hydrogens, it comes out to be 7. And for the carbons, it comes out to be 6.5. So if it comes out really close to a whole number, if it was like 6.99, we could round up to 7. Or if it was 6.01, we'd round down to 6. But if it comes out to be 6.5, we probably don't want to round down or up. But we want to keep the ratio the same and get these all to become whole numbers. Just like we can divide them all by the same number, we could also multiply them all by the same number. So if we multiply these all by 2, it's going to give us 13, 14, 2, and 4. So we kept that ratio the same. We got them all to be whole numbers. Now we're ready to write out the formula. So it'd be C13, H14, N2, and O4. Sometimes we also want to be able to find a molecular formula. So for each empirical formula, there can be many different molecular formulas. The empirical formula is the lowest ratio, but the molecular formula is the actual number of atoms in a molecule. So you need additional information. You don't need just the percent compositions. You're also going to need molar mass. So here's an example. The empirical formula of a compound is C2H3O, and its molar mass is 129 grams per mole. What is its molecular formula? All right, so this empirical formula could have many different molecular formulas. They can be the same, so it could be C2H3O, or it could be twice as big as this, like C4H6O2. It could be like 10 times bigger than this, like C20H30O10. We don't know. So the easiest way to figure this out is to take the molar mass, 129. So that's the molar mass. And then we're going to divide that by the mass of the empirical formula. So my empirical formula, I have 2 carbons. So that's 2 times, 12, plus 3 times the mass of hydrogen, which is 1, plus 16 for the oxygen. So that gives me 43. So 43 is the mass of the empirical formula. And when I divide these, I get 3. So what that tells me is that the molecular formula is 3 times bigger than the empirical formula. So all of these subscripts, this whole ratio, needs to be 3 times bigger in the molecular formula. So my molecular formula is going to be C, and then 3 times 2, so 6. And then H, 3 times 3, so 9. And then O, 3 times 1. So C6H9O3 is our molecular formula. You could check that. We could add up the molar mass, and it should come out to be 129 grams per mole. We'll look for one more example here. This one incorporates everything we've learned in this video. So we're going to find the molecular formula of a compound that contains 80 grams of carbon and 20 grams of hydrogen. And the molar mass of the compound is 90 grams per mole. So this one's going to be 2 parts. We're first going to find the empirical formula, and then we'll use the empirical formula to find the molecular formula. So we have 80 grams of carbon and 20 grams of hydrogen. So to find the empirical formula, we'll convert these both into moles. So carbon, 12 grams of carbon for every 1 mole. That gives us 6.66 moles of carbon. And then hydrogen, 1 gram of hydrogen for every 1 mole of hydrogen. And so that gives us 20 moles of hydrogen. All right, we want to find the ratio between these, so we'll divide them both by the smaller number, 6.66. So this comes out to be 1, and this comes out to be 3. So my empirical formula is CH3. And my molecular formula is going to be some multiple of this. So to figure out which multiple of C3 or CH3 it is, I'm going to take 90, which was given to me as the molar mass. So 90 is the molar mass. And I'm going to divide by the mass of my empirical formula. So 12 for the carbon, 3 times 1 for the hydrogens. So that's 15. So 90 divided by 15 is going to give me 6. So I know my molecular formula is 6 times bigger than the molecular formula. So the molecular formula is going to be C6H18.